दृष्टुं ज्वलन्तं सर्वतोमुखं नृसिंहं भीषणं भद्रं मृत्युं नमाम्यहम्. I welcome all of you to this online classes of our channel. We were discussing last class what is an alcohol, different types of alcohols, nomenclature of alcohol, and isomerism exhibited by alcohols. This class will devote for the preparation of alcohol, how alcohols can be prepared in general by general methods. So when you come to alcohol, ROH, very simple concept of organic chemistry on which entire chemistry of organic compounds depends is one, the Gayatri Mantra, that all organic compounds are derivatives of hydrocarbon. So RH is the hydrocarbon. Alkane has molecular formula CnH2n plus 2. When we substitute the hydrogen atom by a functional group, hydroxyl group, we get ROH, which has the molecular formula CnH2n plus 1 OH. So the hydroxyl group is the functional group. And we want to prepare alcohol. So since all organic compound derivatives of hydrocarbon, we can prepare alcohol from the compounds which have also a group like OH, because we can remove that X group and substitute OH, and OH is an electron attracting group, a negative group. Hence, compounds having equivalent groups can be taken for the preparation of alcohol. So one such is alkyl halide. Halogens are also negative groups, electron attracting groups. Amino group, NH2 group. COOR group, the ester group. They are the groups which are having the similar type of character as OH has. So we can take these compounds and prepare alcohol. So that is the hydrolysis of the organic compounds will give us the alcohol, selected specific organic compounds. Then coming to the second, that alcohol has O and H. If we take a compound which contains O and the O is bonded to the carbon atom, why? The OH group is bonded to always carbon atom in alcohol. So if we take a carbon atom bonded to oxygen by a sigma and a pi bond, then we can break the pi bond and add 2H this side. So H will go to carbon, H will go to O. So the addition reaction of hydrogen of carbonyl group can give us alcohol CHOH. Hence we can say the reduction of carbonyl compounds can be a method, very good method for preparation of alcohols. And gateway of India is Grignard reagent in organic chemistry, because earlier anybody who was entering to India was coming through the gateway, hence it was called as the gateway of India. Like that, any organic compound we want to prepare right from the alkane to all organic compounds, the best compound is the Grignard reagent. We can take Grignard reagent and use alcohol. So we can, with these idea, I will say that preparation of alcohol alcohols can be prepared by the following general methods. So we can keep them in our mind as HRG. H, hydrolysis of organic compounds. One method is hydrolysis of organic compounds. That means we have Rx From RX we will remove H and put OH. So what are those organic compounds? The organic compounds are E, A, A. They are what? E, A, A. E stands for ester and A stands for alkyl halide, and this A stands for amine. So you will not be thinking that how will I remember? No question of remembering. You have your own method of overcoming this. So organic compounds, all organic compounds means ester, hydrolysis of alkyl halide and hydrolysis of amine. What is the theory behind it? We have RX, the organic compound, and we will hydrolyze. This will be hydrolyzed. So we will get the H, X will go, and OH this side, we get ROH. We call this method this. So here we will select the attacking reagent for carrying out this reaction. Then second method is reduction of organic carbonyl compounds. Reduction of carbonyl compound. These are carbonyl compounds. We have aldehydes and ketones. This is the carbonyl group. In carbonyl group, carbon atom is bonded to an oxygen atom by a sigma and a pi bond. Sigma and a pi bond. Pi bond is a loosely held electron cloud, more diffused into the space, is a weak bond. So if we can add 2 hydrogen atoms here, reduction, then pi bond will break, one H will be added to carbon, the other O will be. So this is the, we get here C, OH and H. So if this is R, then RH, CHOH, primary alcohol, that is aldehyde. If this is a ketone, RR, with a ketone, we get a secondary alcohol. So both primary alcohol, secondary alcohol can be prepared from the reduction of carbonyl compounds. Then third method is Grignard reagent synthesis. So Grignard reagent is a very good synthesizing reagent. Almost all organic, right from the alkane, almost all organic compounds are prepared by using the Grignard reagent. So these are the 3 general methods. There are all other methods are there, but we consider general methods. And my dear students, we are not discussing alcohol, writing a book on alcohol. We are reading +2 second year in CBSE or ICSE or CHSE board, and we are intending to appear our entrance exam, JEE or NET or NISER, etc. So whatever study we will make keeping our syllabus into the view, not that we will be reading alcohol. So if you book about alcohol, volumes can be written, but what are the given to us, and we read X plus delta X. X is our syllabus and delta X is our entrance exam. So whatever teaching I am making online, I am keeping 2 things. First, I am covering the syllabus. So by that you will be equipped to appear your board exam with that note, and delta X I will be teaching along with that you can very well know, and that can be useful for your appearing whatever entrance exam you want to appear. Now let's start with first the hydrolysis of organic compounds, hydrolysis of ester, hydrolysis of alkyl halide and hydrolysis of primary amine. So hydrolysis from the organic compounds, the EAA is the method. The whole organic chemistry I will be helping you in writing in 1 page, and so that with that page you can everything at a glance you can make like this. First, organic compounds, ester. So we'll take hydrolysis of ester. So what is an ester? Ester is a alkoxy derivative of carboxylic acid. This is carboxylic acid, RCOH is the carboxylic acid, And if we substitute the OH group by OR dash group, alkoxy group, then you get as RCOR dash. This is ester, this is carboxylic acid, and this is ester. So this R dash may be identical or R dash may be different. So which part will break? This part will break. This side, so this is the alkoxy part will give us the alcohol, and this is the carboxylic part. So this R will not give us alcohol, this R dash will give us alcohol. So when we are depending upon what alcohol we want to prepare, suppose you want to prepare methyl alcohol, then your R dash will be CH3. If we want to prepare ethyl alcohol, then our R dash will be C2H5. So this part will give us, this is the alkoxy part. Alkoxy part will give us the alcohol, and this is the carboxy part will give us the carboxylic acid. So when we take a carboxylic acid, ester or COR dash, this is ester, and treat this with we want to hydrolyze. So hydrolysis always done by either by an acid or by an alkali. Hydrolysis means, lysis means breaking. By addition of a hydrogen molecule will involve in breaking the molecule, hence we call that as the hydrolysis. And these are organic compounds. Organic compounds are always insoluble in water. So by adding water we cannot hydrolyze. So hydrolysis is always done either by an acid or by an alkali. When we use acid, we call that acid hydrolysis. When we are using alkali, we will call that as alkali hydrolysis. So when alkali means which alkali? We will take sodium hydroxide or potassium hydroxide. We will take sodium hydroxide or potassium hydroxide and use it, alkali hydrolysis. And if you take acid, which acid? Na mineral acid. Then which acid is preferred? Na sulfuric acid is prepared, always, not hydrochloric acid. The reason because in sulfuric acid the sulfur is in highest oxidation state, +6 state, so that will not get involved in reactions. But alkyl, the halo acids, they react with alcohol very lightly, they react with alcohol. Hence we will not take halo acids for hydrolysis, we will choose sulfuric acid, the mineral acid. So if you take that mineral acid here, then we take sulfuric acid. This sulfuric acid will subscribe as a molecule of water. Molecule of water. Then what is this molecule of water will react and it will give us silent here. So this will give us RCOH, the carboxylic acid, plus R-OH. This is the carboxylic acid, this is carboxylic acid, and this is our alcohol. This is carboxylic acid, this is our alcohol. And this reaction is a reversible reaction. This is a reversible reaction. This reaction is a reversible reaction. So when you take sulfuric acid, a mineral acid, undergoes hydrolysis to produce a carboxylic acid. So this is the ester, and which part then gives us? So the R- part gives us the alcohol. R- part gives us the alcohol. So when a ester is treated with a mineral acid, undergoes hydrolysis to produce carboxylic acid and alcohol, and both are liquid. Carboxylic acid and alcohol both are liquid, but then how they will be separated? Both are liquid, you will get a mixture of two liquids. So carboxylic acid has higher boiling point than alcohol. Always carboxylic acid is a higher boiling point than alcohol. Why? In carboxylic acid, the carboxylic acid molecules remain in dimeric state because of intermolecular hydrogen bonding. They remain in dimeric state because of intermolecular hydrogen bonding. Hence, they have always a higher boiling point than alcohol. Hence, we will prepare and carry out the fractional distillation. We know the boiling point of alcohol, so the alcohol will be distilled out first, the carboxylic acid will remain in the flask. So very easily, in a very pure form, we can get the alcohol by this method. So I will be using this. Let me take, suppose I want to prepare ethyl alcohol. I want to prepare ethyl alcohol. I want, then what the ester I will take? I will take an ester of ethyl alcohol. I will take CS3, CO, O, C2H5, and this is ethyl acetate. This is ethyl acetate. I will take ethyl acetate and hydrolyze by treating this with sulfuric acid. Is refluxed. So this process is a refluxing, they call it, refluxed. Then what do you get? So we'll break the molecule here. We'll get the CS3, Cu, OH, acetic acid, and the alcohol C2H5OH, ethyl alcohol. We get ethyl alcohol whose boiling point is 78 degrees centigrade, and we get acetic acid whose boiling point is 120 degree centigrade. So they have much difference in their boiling point. We does the fractional distillation, then can be separated by fractional distillation. So this is a very useful method used in the laboratory by this. So children, this equation, you see, when you will read preparation of carboxylic acid, again this reaction you will take, because you are getting acetic acid. This reaction can be used as a preparation of carboxylic acid. When you will read carboxylic acid chapter, this will be a method of preparation of carboxylic acid. When you want to prepare acid preparation properties of acid derivative. So if you reverse the reaction, when a carboxylic acid is treated with an alcohol in presence of a mineral acid, an ester is produced. When you prepare ester, this reaction again you will use there as a method of preparation of ester. And this reaction already we have studied in chemical equilibrium chapter. Chemical homogeneous equilibrium. So there you have in liquid system we have studied. And when you read chemical kinetics in your second year you have the chapter, there you study also this reaction is a second order. This is a first order bimolecular reaction, pseudo unimolecular reaction. Again we will be teaching you, while teaching you chemical kinetics, this reaction we will study there as a first order bimolecular reaction called as a pseudo unimolecular reaction. This one reaction in the preparation will be so useful to this. So we'll take so we have done now preparation of, so now we can do this by using an alkali. We can do this reaction by straight. In case of alkali, the reaction will not be a reversible reaction. So if you take an alkali, so suppose you take ethyl acetate, CS3, CO, OC2, H5. If you treat this with sodium hydroxide, then this sodium hydroxide will hydrolyze this. So C2H5 is a minus, and this Na is plus, and OH is minus. So you have this C2, you have C2H5, OC2H5, this is Na plus, OH minus. So this OH will go to where? Will go to this acid. So they will produce the alcohol. It will produce acid CS3CONA. This will produce as CS3COONA plus C2H5OH. Now CS3CONA is a sodium acetate, and you will get ethyl alcohol. So we get a salt here, but generally the best method is to get the hydrolysis of ester by an acidic medium. So this is a laboratory method of preparation of ethyl alcohol and also preparation of the acetic acid. When you will read carboxylic acid, we will use this method. When you will read law of mass action, when you will read chemical kinetics, all in everywhere you will use this reaction. So this is a hydrolysis of ester. So second method we are taking as a hydrolysis of alkyl halide. Alkyl halides are other alkyl halide is other alkyl halide is called haloalkane. It is RX, the alkyl halide. So X is either chlorine, bromine, or iodine, and we want to prepare this by using get alcohol. Alcohol. So what we will do now? We have to remove X. What is X? Maybe chlorine, bromine, iodine. Chlorine, bromine, or iodine. So then that how they will go? If you use alkali metal, either sodium or potassium, and we want OH here. So OH. Then what the reagent we will take? We will take sodium hydroxide or potassium hydroxide. So if you take sodium hydroxide, or you can use potassium hydroxide, then this will undergo hydrolysis and you will get alcohol ROH and X and A. Why? Now you have read inductive effect, so there is always a drift of electron take place towards X. Plus the X is a electron attracting group, so always there is a minus I effect. Because of minus I effect, this halogen has a negative charge and this alkyl group has a positive charge. That means alkyl group has a what character? A carbonium character. Carbon with a positive charge is called the carbonium character, and this sodium is positive and OH is negative. So this Na will definitely go to whom? To Na. So this will come as NaX, NaX, and you get this as the alcohol. So this is the we use this aqueous. So what we will take? We will take aqueous sodium hydroxide solution of sodium hydroxide. This. So it is called that means what? When an alkyl halide is treated with aqueous sodium hydroxide or potassium hydroxide, undergoes hydrolysis to produce alcohol and the salt of sodium. This halide salt of the sodium. Suppose you take ethyl bromide C2H5Br, ethyl bromide, and we treat this with sodium hydroxide aqueous solution prepared in this. So this will give us C2H5OH, ethyl alcohol plus sodium bromide. This happens, sodium ethyl alcohol, we get this. So what is the order of reactivity of alkyl halide? The order of reactivity of alkyl halide is Ri. Alkyl iodides are more reactive than alkyl bromide, are more reactive than alkyl chloride. The order of reactivity is alkyl iodide is more reactive than alkyl bromide, is more reactive than alkyl chloride. So that is the reason we are choosing this alkyl bromide to this reaction. Now this is the very useful method for preparation of alcohol, easy method, but there is one difficulty in this method. Now what you have got? You got alkyl halide, and what is this? You got ethyl alcohol. Suppose we have taken a flask, a round bottom flask, we have taken the alkyl halide, we have added sodium hydroxide. Now the reaction is formed in the container. Who is there? Alcohol is there and alkyl halide is there and sodium hydroxide is there. Sodium hydroxide is there. Then what will happen? The sodium hydroxide slowly will become alcoholic sodium hydroxide. Alcoholic sodium hydroxide. So we have studied in our alkene chapter, when an alkyl halide is treated with alcoholic sodium hydroxide, undergoes elimination reaction to produce an alkene, that is called dehydrohalogenation. So this is a limitation of this method. So when you take this, we have read in our alkene chapter, when you take an alkene, say CS3, when you take CS3, CS2Br and treat this with alcoholic sodium hydroxide or potassium hydroxide. This undergoes elimination reaction. This undergoes elimination reaction. Means what happens? So this one hydrogen atom from this place and one bromine atom from this place, they form HBr. This reaction is called elimination reaction. So this HBr is formed, eliminated. HBr is eliminated. This HBr will react with whom? With sodium hydroxide. So this HBr, hydrogen from this place and bromine, they come out as HBr molecule. So by this reaction, what happens? Minus HBr take place. So this HBr reacts with sodium hydroxide to form sodium bromide and water. This HBr will react sodium hydroxide to form sodium bromide and water. And what remained here? Here it remains CS2 double bond CS2. We got ethylene. So this is a one limitation of this method. This is a limitation of, though it's very easy to get alcohol, but with the course of the reaction, the concentration of alcohol increases. As a result, the sodium hydroxide aqueous becomes alcoholic sodium hydroxide. So instead of this substitution reaction, this reaction take place, elimination reaction take place, and alkene. So this reaction is called dehydrohalogenation. So this reaction is called substitution, nucleophilic substitution reaction, because we are replacing the bromine by whom? By OH. So we are replacing the bromine by OH. What is OH? Negative group. What is negative group? Nucleophile. So nucleophilic substitution reaction takes place. So this reaction, nucleophilic substitution reaction will not undergo, what will subsequently it will give us an alkene. Hence we have to this method, hydrolysis, the best thing. This sodium hydroxide is replaced by moist silver oxide. So in place of sodium hydroxide or potassium hydroxide, what is taken? Moist silver oxide is taken for this. Moist silver oxide means what? We have silver oxide plus water. So this is what it remains in this remains as silver hydroxide. This remains as silver hydroxide. The moist silver oxide, this remains what? Silver hydroxide. Is as good as taking silver hydroxide. So if you take this, what will happen now? We will take the alkyl halide C2H5Br, and this will react who? The moist silver oxide will react. So what will happen? This silver and bromine, they form silver bromide. The silver bromide is a precipitate and we get the ethyl alcohol. So we know silver chloride, silver bromide, silver iodide, all are precipitates. Silver iodide is insoluble precipitate. Silver bromide is soluble in concentrated sodium hydroxide, concentrated ammonium hydroxide, and silver chloride is soluble in dilute ammonium hydroxide, forming a complex. So this is very easy to separate because the precipitate will remain inside at the bottom of the container and we can take. So we will take that when an alkyl halide is treated with moist silver oxide, undergoes hydrolysis to produce ethyl alcohol. So depending upon the alcohol you want to prepare, you will choose the RBR, that alkyl. If you want to propyl alcohol, you will take propyl bromide. If you want to prepare isopropyl bromide, isopropyl alcohol, we will take isopropyl bromide. So depending upon the alcohol we take, we will choose this. So this is another method for this. Now the next method in this hydrolysis of organic compound is hydrolysis of amines. That is the next is hydrolysis of primary amine. So what is primary amine? Hydrolysis of primary amine. So what is primary amine? RNS2. And what I want to prepare, RNS2 will take. And what is our interest? Our interest is to prepare ROH. So this is our aim of experiment. In practicals, you have an AIM-PAM experiment, then principle. That means what? We have to take out NH2 and put OH there. Just children, I am giving a question to you, just to think how we will remove NH2 and put OH there. Just you have a think, go on thinking this, and I will come next class, I will be teaching you how to prepare, how to remove this NH2, how to substitute the NH2 group by a OH group in my next class. Just I am giving you homework, you think how NH2 group can be eliminated and OH group can be substituted.